Okay, so the next section of chapter 3 is titled Measures of Variation. The last section was about measures of center, and the values you calculate will describe how the data varies. So, sorry, I'm messing with my face that I don't cover up all these important words here. Variation is the single most important topic in statistics. You're going to see formulas that will help you calculate these measures of variation, but this is not a study of arithmetic. Your calculator can generate these values. I'm going to ask you to do it once for me written. I will not ask you to do it on an exam. You will not have to do it by hand on a quiz. I want you to do it by hand once and submit it to me once so that you understand how important calculators are. I know sometimes the calculator can be frustrating, but when you have a large amount of numbers, calculators come to the rescue. Okay, so study hint number 1, that part 1, this video that I'm creating, has basic concepts of variation. Part 2 has additional concepts that I will be testing in the homework or asking you about in the homework, but don't spend too much time memorizing any formulas and doing too much arithmetic. So generally, variance is, there are 3 ways to measure. We have 3 formulas. Range, standard deviation, and variance are the 3 measures of variation. So mean, median, mode, measures of center. Range, standard deviation, and variance are measures of variation. So when I show this graphic, you see people, and I can use the word vary to say the width of their smiles vary, the length of their hair varies, the size of their eyes vary, right? When you look at these roosters, whatever that red thing's called, varies. And so what these numbers that you're studying about in this video help you compare is the level of variation among set. Be it, and this was just a really fun pattern that's called self-similarity. So they vary. It's like one pattern that just kind of copies on itself. Anyway, so again, don't focus so much on the calculations as much as how these numbers describe variation. So you've got more symbols. Again, try not to be burdened with the symbols. The symbols are there for purpose. But you'll see that you've got a set of symbols for population. So you have population standard deviation, population mean. Mean is a measure of center, and then population variance. And then directly underneath, you could look at it as the second row, you have sample standard, sample mean, and sample variance. That goes to the definition of population versus sample. Right? So I won't speak too much about that. We'll come back to it later. So right out the gates, range is the easiest of the 3 to calculate. To find the range of a set of data, you find the highest value, you find the lowest value, high minus low. That's what they calculate as the range. So you would say, you know, if you have a percentage, it ranges anywhere from 0 to 100. Again, the easiest of the 3. And then you have standard deviation, which looks crazy difficult. Again, don't focus too much on memorizing this. I do want to calculate it once or twice. I'm going to ask you to calculate it by hand. But this is the formula. Let's see what you can remember from previous formulas. This is the sum. X represents any value in our data set. Mu is the symbol that represents the population mean. The reason it's squared, we'll talk about in a minute. Capital N represents the number of values in the population. So what the standard deviation for the population does is it adds up all of the distances from any value that's in the set away from the mean. So generally, it calculates the distance from each point to the mean and takes the mean of the distances from the mean. So again, you can read this slide word for word. I am not, as I'm describing it to you, this just comes straight out of your text. We will be using this formula, but I will not ask you to do it on an exam, and instead I will show you how to get the calculator to generate it for you. Caution when using a calculator to find standard deviation. Identify the notation that's used by your calculator so that you can get the sample standard, and our calculators give us the sample standard deviation, not the population standard. It's a slight tweak in the formula. I'll show you that in this slide. So the formula I spent some time speaking about has capital N in the denominator under the square root sign, and that would be for the population standard deviation. When I'm looking here at the sample standard deviation, a couple of changes. Instead of capital N, it is lowercase n minus 1. And instead of the mu, we are taking each point, each data value from the set, and we're finding its distance away from the sample mean instead of from the population mean. So generally, what is standard deviation? It's how much data varies from the mean, how far the bulk of the numbers are when you consider the mean, and the mean is somewhat in the center of the data. If you could visualize it, you'd be like, it's like right there, right? So I want to give you 3 different sets of numbers, all with a different center. This one's centered right at 3. This one's centered, both symmetric here. All 3 of these are symmetric data, so it's easy for you to tell where the center is. This center, if it's 7, 8, 9, 10, right about 8.5, right? So these sets are ordered from the greatest standard deviation to the least standard deviation, and hopefully you can visually see that the top set of data is more spread out. The second set of data is pretty clustered, but that the higher values are at the end. And when you look at the third set of data, it's getting closer to this symmetric, but with a peak in the middle kind of data. So I wanted to just calculate the standard deviation of one of these 3 sets, and then have you try to do this on your own as well when I give you the handwritten work that I want you to submit this week. So I will come back and actually calculate the standard deviation, but I want to talk about the reason why standard deviation is so important, and it has to do with the empirical rule that says that if you have data that's normally distributed, that 99.7% of all data lie within 3 standard deviations of the mean. So think about that. If I knew what the mean of a population was, and then I can calculate the standard deviation, then I would be able to predict almost 100% of the data would lie between a couple of values. So this information that I'm presenting to you might not be that useful. I made it sound like, think about that for a second, how amazing that would be that we could calculate what the sum of the last 4 digits of your cell phone are going to be. But there's also much more valuable information that is normally distributed, like height and weight and IQ, that we should be able to make claims or statements about whether or not you have a high IQ or whether or not you are overweight and things like that based off of what the mean of this data is, because it is normally distributed. So again, 99.7% of data fall within 3 standard deviations of the mean, almost 100% of the data. And what I welcome you to do on this slide is think about your cell phone number and think of the last 4 digits of your cell phone and then add them up and see where that lies. I'm doing it in my head here. Mine is 11. So when I look at 11, it shows that, 20 to 30-ish of the cell phone numbers that are being recorded in this data are lying, in that set. And if we all were to report what the sum of our 4 digits are of our cell phones, and we created a histogram, that ours would do this too. And so that's the true beauty of statistics and finding data that's normally distributed, is that it just naturally occurs, and that the empirical rule says that not just 99.7% of the data lies within 3 standard deviations, but even more specific, that 68% of the data lies within 1 standard deviation, 95% of the data lies within 2 standard deviations, and then basically 99, almost 100% of the data lies within 3 standard deviations of the mean. So without that measure of standard deviation, we wouldn't be able to even speak to that. So that was kind of a place here for me to pause, ask you a couple questions, get your calculator, get something to write with, and I'll join you in the next video.